Hello friends, this is Bharsat Ramdas Pandit working as Assistant Professor in Chemistry at Maratha Vidya Prasarak Samaj, Nasik. In this video lecture, we are going to study calculations used in analytical chemistry. So, first of all, we should know what is meant by analytical chemistry. Analytical chemistry is the branch of chemistry which deals with the separation, identification, and determination of the amount of the compounds present in a samples. Right. So in this subject, during the some calculations, we are using some basic units. They may be SI systems and they may be CGS systems. Right. So first of all, we have to see 7 fundamental basic units. In that, you will be see here physical quantities, we call them, right? In this case, first is the mass, and in the SI unit, you will take kilograms, and abbreviation is the kg. And for the second, length, the SI unit is the meter, and abbreviation is small m. And next physical quantity, that is time. The SI unit is the second, and abbreviation is small s. And temperature, SI unit is the Kelvin, and abbreviation is capital K. And the next is the amount of substance. Okay, so that is the SI unit is mole, and the abbreviation is small letter mol, mole. And the next physical quantity, that is electrical current. The SI unit for the electrical current, that is ampere, and the abbreviation is the capital A. And the next physical quantity, that is luminous intensity. Okay, and the SI unit for the luminous intensity, that is candela, and the abbreviation is the small letter CT. In this way, we can take some other units, that is volts, hertz, coulombs, and joules, and etc. So all these some important units for the measurements you have to remember. And next we have to see some common SI derived units. They are, you will see in the tables, physical quantities and their name of SI units and their symbols. So first of all, we will see here area. The SI unit or the area, that is square meter, and the symbol is in this way. Okay, meter per square. And volume, cubic meter is the SI unit, meter cube. Okay, next for the density, kilogram per cubic meter is the SI unit for the density, and kilogram meter cube minus cube. Okay, and the next is velocity, the SI unit for the velocity, that is meter per second. Okay, and here symbol is the meter per second. And the next physical quantity, that is force, the SI unit for the force, that is Newton, and the SI symbol for the kilogram meter per second square minus square. Okay, so the next is the pressure, the SI unit for the pressure, that is Pascal. Okay, and the SI symbol, that is Newton per meter square, kg meter square second square. Okay, next physical quantity, that is energy, the SI unit for the energy, that is joule, and SI symbol for the kg meter square, okay, second square in bracket capital Nm. Next physical quantity, molarity. Okay, and the SI unit for the molarity, mole per cubic meter. Okay, and here mole per meter cube, minus cube is there. Okay, the next is the molality. SI unit for the molality, mole per kilogram, and the SI symbol for the molality, that is mole per kg. And the next physical quantity, frequency, and SI unit for the frequency, that is hertz. Okay, and the symbol for the SI frequency here, hertz per second. Next we have to see very best example, you know very well, that is amount of memory in mobiles. Everyone having mobiles. Okay, so they have know the amount of memory. You can see in the KB or MB or GB or different units for the memory. So we have to see, if you want to write 30 KB into the byte. Okay, so you will write here 30 into 10 raised to 3. Okay, so in this way you have to write. And next, if you want to write 30 MB into the bytes, so you will write here 30 into 10 raised to 6, right? Or you can write also in this way also, 30 into 10 raised to 6 bytes, that means 30 MB, right? And the next is 30 into 10 raised to 9 bytes, means the 30 GB is there. Okay, and the next is 30 into 10 raised to 12 bytes is equals to 30 TB. And the next is the 30 into 10 raised to 15 bytes is equals to 30 PB. Okay, so you will see here the units of the memory, or the amount of memory into the KB, MB and GB and TB and PB. So you will see here the difference is unit, and the here 10 raised to 3, 10 raised to 6 and 10 raised to 9 and 10 raised to 12 is there, and finally is 10 raised to 15. So you have to remember, so smaller unit of memory, that is KB, and next one is the here bigger than KB is MB. So in this way the bigger unit is the amount of memory, that is PB. And in this way you have to write, you have to remember this order of that amount of memory. And next we have to see some prefixes for the units. Okay, so you will see here the tables. Okay, how many 10 prefixes are given for you, and their abbreviations and their multipliers. Okay, we have seen in the amount of memory like this. We have to see here peta. Okay, abbreviation is P, and multiplier you can use 10 raised to 15 is there. Okay, for the tera, abbreviation is capital T, and multiplier is 10 raised to 12 is here. Okay, and for the giga, abbreviation is capital G, and multiplier is 10 raised to 9. And for the mega, and abbreviation is the capital M, and multiplier is 10 raised to 6. And next prefix, that is kilo, abbreviation is capital K, and multiplier is 10 raised to 3. And next is hecto, abbreviation is small h, and multiplier is 10 raised to 2. And next is the deca, abbreviation is capital, or not capital, small da, and multiply is 10 raised to 1. Okay, and the next is iota, abbreviation is capital Y, and multiplier is 10 raised to 24. And the next is the zeta, abbreviation is capital Z, and the multiplier is 10 raised to 21. And the last one in this table, hexa, and the abbreviation is capital E, and multiplier for the hexa, that is 10 raised to 18. So in this way prefixes for the units we have to remember, and their multiplier also we have to remember for the calculations in analytical chemistry. One more table we have to see for the prefixes for units You will see again here the prefixes and abbreviations and multiplier. You will see here the deci. Okay, abbreviation is small d, and the multiplier is 10 raised to minus 1. And next is the centi. Okay, decimeter, centimeter, millimeter, micrometers, all these things like this. Okay, centi abbreviation is small c, and the multiplier is 10 raised to minus 2. Next prefix, that is millimeter. Okay, prefix is milli, and the abbreviation is small m, and multiplier is 10 raised to minus 3. The next prefix, that is micro, abbreviation is mu, and multiplier is 10 raised to minus 6. And the next prefix, that is nano, abbreviation is small n, and the multiplier is 10 raised to minus 9 is there. And the next prefix, that is pico, abbreviation is small p, and multiplier is 10 raised to minus 12. The next prefix, that is hemto, abbreviation is small f, and the multiplier is 10 raised to minus 15. And the next prefix, that is atto, abbreviation is small capital or a, small a, and multiplier is 10 raised to minus 18. The next prefix, that is gypto, and the abbreviation is small z, and multiplier is 10 raised to minus 21. And next prefix, that is yocto, abbreviation is small y, and the multiplier is 10 raised to minus 24. So all these abbreviations and multipliers of prefixes we have to remember for the calculations purpose. For example, if you will calculate the smaller scale of length, right? So in this way you can write, if you want to write 30 into 10 raised to minus 2 meter. Okay, so I will write here 30 centimeter. So this is the bigger unit and this is the smaller unit, right? So in this way you can convert centimeter into meter by writing the 10 raised to minus 2, or meter into centimeter. Okay, by reducing this quantity 10 raised to minus 2. And the next, if you will see the volume, okay, in liquid, right, so that is the 30 into 10 raised to minus 6 liter, right? You will write in this way 10 raised to microliter. The next unit, that is wavelength of radiations, and in this way you will write there 30 into 10 raised to minus 9 meter, you can convert into 30 nanometer, right? All this conversion we have to remember. And you will see here mass units, kilogram, smaller unit gram, and next is the smaller than gram is milligram, and again smaller mass unit is the microgram. In this way you will see the mass measurements. You will see here 1000 microgram is equals to 1 milligram. Next is 1000 gram is equals to 1 kilogram. Next is 1000 milligram is equals to 1 gram. And here 100 kilogram is equals to 1 quintal, and 100 kilogram is equals to, or you can write in this way 10 quintal is equals to 1 ton. And here next conversion you can see 10,000 quintal is equals to 1000 ton. The next, some useful conversion factor we have to see, they are given in front of you. 1 Armstrong is equals to 10 raised to, next conversion, that is 1 meter is equals to 10 raised to 9 nanometer. Next is 1 millimeter is equals to 1000 micrometer, and the 1 micrometer is equals to 1000 nanometer. 1 AMU is equals to 1.66 into 10 raised to minus 27 kilogram. The 1 calories is equals to 4.184 joules, and the 1 ox is equals to 10 raised to minus 7 joules. Like this, 1 centimeter square is equal to 10 raised to minus 4 meter square, and 1 centimeter minus cube is equals to 10 raised to minus 6 meter minus cube. The 1 gram centimeter minus cube is equals to 10 raised to 3 kg meter minus cube, and 1 liter is equals to 10 raised to minus cube meter cube is equals to 1 dm cube. 1 atmosphere is equals to 760 mmHg. The next is 1 kilocalorie per mole is equals to 4.18 into 10 raised to minus 19 joules. 1 electron volt is equals to 1.602 into 10 raised to minus 19 joules. So in this way we have to remember all these useful convergence factors.